Hey, Sylvan Park super scientists. Today, let's find out about what sinks and what floats. And so to do that, we have a glass of water. And of course, I have my science journal here. And we're going to write down what we do. First thing we're going to do is we're going to take a car. And we're going to ask the question, will this sink or float? What do you think? What's your prediction? You will write down your prediction, and then let's do it. Whoa! It sure sank, didn't it? Maybe that's because it's so big. Let's try something smaller. Whoop. Something smaller, like a Skittle. Here's a Skittle. Right here. Let's take a green one. What do you think's going to happen? What do you predict? Is it going to sink or is it going to float? Ooh, it certainly sank, didn't it? Well, that shows that either big things or small things can both sink. That's because they're dense. They have a lot of weight for the amount of volume or space that they have. But here's something else. Let's try this ball. It's pretty big, isn't it? What do you predict is going to happen? Is it going to sink or is it going to float? Whoop! Look at it float. That's because it doesn't have much weight considering how big it is. Now, what you're going to do is a bunch of experiments to see whether things sink or float. First thing you're going to do, we need to make some salt water, because it turns out that different liquids can have different density too. Some liquids can sink in other liquids. So to do that, what we want you to do is to make some salt water. And here, how you do it. Take a measuring spoon, a big tablespoon, and put 2 tablespoons of salt into water, into the cup, and fill the cup up to the line where it says 1 cup with water. And then you stir it up. This is adding salt to the water. What do you think that might do to the density of the water? Later on, what you're going to do, and I'm really eager to see what happens as you do this, you're going to take an object, 1 egg, raw, and you're going to drop it, not actually drop it, but place it carefully in 2 different kinds of water. Water with salt and water that just comes out of the faucet, tap water. Now, do you predict that it will float? Will it float in the salt water? Will it float in the regular water? Which water might be denser? This is for you to figure out and do it later on. And I think you'll enjoy it. Just don't throw the egg in so that it breaks in your glass of water. Now, another thing that we want you to do is to try and figure out that the density of different liquids. They're both liquids, but can you predict what liquid will be more dense than another? So to do that, I want you to take some salt water that you've made and pour some into the cup like that. And you can put a little blue coloring in there so it makes it very distinctive. Salt water is blue. Then stir it up a little bit. Isn't that something? And then add about 1 inch worth of oil to it. And see what happens. Does it mix together? Which one is more dense? Which one sinks to the bottom? And which one is less dense? That is, it floats to the top. course, you can make a drawing in your science journal showing if they're all mixed together or if one layer is less dense than the other and floats on the more dense one. Then you can do all kinds of things. You can take anything when you have your two kinds of liquids. Take anything that you find around, like the pen top, maybe a nail, an acorn, a stick. What else? Maybe a raisin.
A rock.
A rock, yeah, a rock. That's a good idea. A rock, and drop it into the two liquids and observe what happens. And of course, before you do it, predict what will happen when you put it in there. And I think you're going to see that you're going to learn a lot about what materials float and what liquids float and what liquids are very dense and don't float and sink. And we hope you have a good time doing it. Now you might be wondering why. What difference does this make in the real world? And it turns out that the Earth, its density issues and what is more dense and what is less dense is very important in how the Earth behaves in all parts of the Earth, including the atmosphere, which is like wind and hot air and cold air, and also the oceans. And the oceans move by currents that are basically driven by differences in how dense the ocean water is. And that's really important in controlling our climate. See you next week. Bye-bye. Have a good week, super scientists.